This video will go over hypothesis testing, and specifically we're going to be looking at testing a population mean using a t-test. So recall for means, we have to verify that the distribution is normally or approximately normal. They could tell you the population follows a normal distribution. If they don't tell you that it's normal, then we have to check that condition that our sample size n is greater than or equal to 30. In addition, our t-value is our data minus mean over standard deviation. For us, we have x bar minus mu divided by s divided by square root of n. If you're going to use a chart for t-values, you also will need the degrees of freedom. Today we'll be using our calculator to find our p-values. So we'll calculate our test statistic by hand, which is our t-value, and then we'll verify that in the calculator and let the calculator get our p-values. Okay, so just a little reminder here about all of our steps in hypothesis testing. First, we have to determine the null and alternative hypotheses. 2, we have to select a level of significance alpha. If it's not given, we'll figure out what to do with that, but really most of them will be given. An appropriate level for the situation would be, depending on how critical it was, for something like a medical condition, you probably want a pretty small alpha. Otherwise, it doesn't matter. You can do the 0.05, 0.1, 0.01. Step 3, we're going to find the test statistic. This is your z or t value. Again, we will be doing this by hand. And then in step 4, determining the p-value, we will use our calculator to find that. You can find it using the chart, but we have this great piece of technology, our calculator, so we may as well use it. Step 5, we'll make a decision, and that will be to reject or not reject the null based on our alpha and p-value. And then finally, step 6, we will state the conclusion. Remember that conclusions are always written for the alternative, so we either do or do not have evidence for that alternative claim. Okay, so let's look at an example. Statistics students believe that the mean score on the first statistics test is 65. A statistics instructor thinks the mean score is higher than 65. He samples 10 statistics students and obtains the scores 65, 65, 70, 67, 66, 63, 63, 68, 72, and 71. He performs a hypothesis test using a 5% level of significance, and the data are assumed to be from a normal distribution. It's actually really good that they tell us it comes from a normal distribution, because if they didn't tell us, we would have to check our n, and because we're only sampling 10 students, that wouldn't be large enough for us if it wasn't told to us. So that is great. Okay, so step 1, determine the null and alternative hypotheses. So anytime we're doing this, we have to think, are we looking at testing a mean, like an average, or is the problem talking about a proportion, which would be p? In this case, we're talking about the mean score, as we can see here, so we know that we're going to be dealing with mu. Now, for the null, it says a statistics instructor thinks the mean score is higher than 65, and so that's going to be our alternative. What the students believe is that it is 65. So for our null, we'll have mu equals 65. That's the average score on the exam. And then the instructor thinks it's actually higher, so I'll do a greater than sign here. And I just put a little blurb that this, again, is what the instructor thinks. Step 2, select a level of significance alpha. This time, again, we were fortunate because they told us that we were using a 5% level of significance. Remember that we always write our percentage as a decimal for alpha, so our alpha equals 0.05. Okay, so we've got all of our information here. I'll save the data so if we need it later we can use it. It doesn't look like they give us any other information in the example. We've got the data here, we've got what the students think and what the instructor thinks. Okay, so step 3, find the test statistic. So doing this by hand, I'll just revisit that formula. We've got our x bar, which is our sample mean, minus mu. Mu was given from our null, divided by S, which is the sample standard deviation, divided by N. So it looks like we've got mu, which was 65, and then we've got N because we sampled 10 students. So we're missing X bar and S. Luckily, they gave us data. So our data here, we're going to have to plug this into the calculator, and then we'll run a one variable stat on our data to give us this X bar and this S. So let's go ahead and grab that calculator. Let me clear this out. Okay, so stat edit, and I've actually already put the information into the calculator, so just enter it into any list that you want. So I've got the 65, 65, and then all 10 of those. So if I scroll down here, I've got all 10 data entries. So let me quit out of that, get back to the home screen. So to run our one variable stats, we're going to do stat, calc, one variable stats. The list that I used was L1, but if you had it in a different list, you could use that. So just make sure you type in L2, L3, whatever list you're using. I'm going to skip over frequency list because our frequency is just 1, and then we will calculate. So from this menu, we get our X bar, our sample mean, and we get our sample standard deviation S right here. So let me go ahead and put that up on the screen. So we've got our X bar is 67 and S, I just rounded to 4 decimals, but again, just whatever the problem needs. We're going to find the p-value in the calculator, so this isn't really critical. So I would say 4 or 3 decimals would be okay. Okay, so let's see. We've got all our information. We've got the X bar over on the right, 67. We've got our mean from our population, which we had in the problem. So let's go ahead and find our t-value. So 67 minus 65, just plugging in the information in the numerator. And then in the denominator, we've got our s divided by square root of n. If you're wondering how I got this 1.98 for the t-value, let me go ahead and show you that. So I'm going to take 67 minus 65, so parentheses, 67 minus 65, close parentheses, divided by, I'm going to open up another set of parentheses, and we're going to do 3.1972, and then divided by square root is a second function, so square root of 10, and then I'm going to close parentheses on my denominator and press enter. So I got 1.978, but t values and z-scores can be rounded to 2 decimals, so I just rounded it to 2 decimals here. Okay, so that's all done. Now we need to determine the p-value. So the p-value is going to be found in our calculator. So let me go back to that. Let me clear this out. We're going to go back to stat. This time we want to run a test to give us our p-value. So we can see all of the choices here. We know that we don't have a z-test because we're using a t-value here. So I'm going to go down and press our t-test. And we have some more choices here. We have our data, which we do have raw data. If we weren't given raw data, we would just select stats, and then we could enter that in. So let me show you what that looks like. So if we had stats, this one is filling in for us from the list, but this would not be here if I had not already put my data in. So let me go back to data so it runs the raw data. So we've got our population mean of 65 that we can see from our mu here. We've got our list where our data is, so mine is still in L1. Our frequency is 1, meaning we're only going to use the data once, so frequency 1. And then we had a greater than, so I've arrowed over to that. And then let me go down to calculate. and that will calculate our p-value. So we can see that the mu is greater than 65. That was our alternative hypothesis. We can verify our t-value, so rounding, it's exactly the same. And then our p-value from our calculator, we get 0.039648 and some change here. P-values, we're going to round to 4 decimals, so I'll round it to 0.0396. Now the other piece of this is drawing that normal curve and shading with the area. So I've drawn it here. I've drawn the t equals 0 in the middle, just like z equals 0 in the middle. I've drawn my positive t value, so it's over to the right. I've shaded because it's greater than, and then I've just put my p-value there. Okay, so we've got our test statistic, we've got our p-value. Now it's time to make a decision and draw a conclusion. So making a decision, we're going to compare our p-value to alpha. If the p-value is less than alpha, then we reject the null hypothesis. So we always ask the same question every time. Is our p-value less than alpha? So on the screen we can see from our calculator, our p-value is 0.0396, and our alpha for the problem was 0.05. So we'll just write that inequality with a question mark. We're going to answer yes or no. In this case, 0.0396 is less than 0.05, so yes, we reject the null. Lastly, we have to state the conclusion. So because we reject the null, that means we do have sufficient evidence to support our alternative claim. So let me just put the example back in here so we can remember what our claim was. So statistics students believe that the mean score is 65, but the instructor thinks that the mean score is actually higher. So our conclusion would be there is sufficient evidence to support the claim that the mean exam score is higher than 65. So we would actually have evidence to support that instructor's claim.